Okay, today we're going to look at 7.1, symmetry. We're going to have two parts, type 1, where we're looking at graphs, and type 2, where we're looking at how to do this algebraically. So the number one thing you want to remember with symmetry is you want to look for symmetry. So if I was going to guess that I was going to say, I'm looking at this problem, where could there be symmetry? Well, if I look right here down the what axis? Y-axis. If I look down the y-axis, you can see that the left and the right match each other. The left and the right match each other. So left and right match each other. Then this type of function is even. Okay, it's even. It's matching on both sides. Okay, well, let's look at this one. Now, I know this isn't a perfectly drawn circle or oval thing, and you could type this into Desmos or Google or some sort of graphing calculator, and you would see something like this shape. But if I drew a line here, do the left and the right match each other? If I could draw perfectly, yes, they would match each other. Now, there's another piece that also matches, the top and the bottom. So if the left and the right and the top and the bottom match each other, then there's one other type of symmetry. It's actually through the origin. So in other words, this half has to match this half. So when I flip it over the origin, or I flip it, then flip it, right? If I flip it over the y, then I flip it over the x, it's the same thing as flipping it over the origin. That is an odd function. So what I want to do here in this problem is I want to ask myself, is this even or odd based on these two ideas? Okay, Well, in this case, let me check. Does it flip over this axis? When I take the things here, so now we want to look at this problem. And when I take the things here, is it the same on the left and the right? No, it's not. So now I'm going to look at the origin. And if I rotated it about the origin, would this rotate up to this, and would this rotate down to that? So in other words, if I flipping twice, flip, does it give me the same thing on both sides? And the answer in this case is yes. And so this is an odd function. So what we're looking for is, first, is it symmetric about the x-axis? If it is, it's even. Okay, pretty simple. If you can rotate it 180 degrees, or flip it twice, or rotate it about the origin, then it's odd. And those are our only two options. If it's not those two things, then it's neither. The second type of symmetry, or really the same type of symmetry, but viewed in a different way, is if we can look at these algebraically. And so what we want to do is we want to check even. We're going to check f of x is equal to f of negative x. Well, what does that mean? What does it mean to put negative inside of the function? So let's look at this first example and see what happens if we do that. I have y equals, so that's my f of x, but I want to make negative x. So I'm going to replace every x with negative x. Notice I did that inside of the square. That's very important, inside of the square. Why? Because the negative is inside this piece. So it has to go inside the square. But what is negative x squared? Well, that's just x squared. So did we get back what we started with by plugging in negative x? We did. We ended up with the same exact answer for both f of x and f of negative x. So that means that this function is even. Okay, odd functions require one more step. Okay, odd functions require f of negative on the inside to be equal to negative on the outside. So what I'm going to do here in this first step is I'm going to rewrite this with the negative on the inside. So y equals 3 negative x cubed minus negative x. Okay, so I've taken the negative x and I've substituted in for both. So what do I get? Well, that's 3. What is negative x cubed? Well, negative x times negative x times negative x would be negative x cubed. So that's a negative x cubed. What is a negative times a negative? Positive, so positive x. So in this case, my f of negative x, this piece here, did not match. They don't match. There's a positive here, negative here, positive here. They're not the same. So what I need to do is I need to check this piece. I need to say, well, what if I make the whole function? What if I make the whole function negative? So I'm saying negative y equals the original 3x cubed minus x. So I have to move the negative to the other side. So y equals, well, that'd be negative 3x cubed. X, and then negative is a positive x. So does this thing match this thing? Hey, negative, negative, positive, positive. These two match, which means this equals this. And that is an example of an odd function. Okay, so graphically, you're looking for left and right to match for even, and you're looking for the odd functions to rotate 180 around an origin. For algebraic, you're looking for even, you're looking f of x equal to f of negative x. And for odd, you're looking for f of negative x equal to negative on the outside of f of x. Okay, it may take a few attempts to kind of get the hang of which one goes where, but one thing that I do is I always do this one first because that's one step. So you can always check even functions faster than you can check odd functions because you have the original and you have to do this step for odd anyway, so you might as well check if it's even to begin with.